Welcome to the Explainer. Today, we're diving into the underlying architecture of Linux security. And to really wrap our heads around it, I want you to picture the Linux operating system not just as a piece of software, but literally as a highly secure medieval castle. Inside this castle, you have a treasury, your data, your running processes, your vital system resources. And just like any impenetrable fortress, you absolutely need a meticulous system of guards, access passes, and ultimate rulers to keep the whole shebang secure. So, who really controls your computer? It's a serious question, right? When you fire up a server or log into a workstation, how does the system actually know what you are allowed to touch, read, or completely destroy? Well, in the Linux world, user accounts are the absolute fundamental security boundaries. They stand between different people, and they stand between the programs that run commands. Every single process on the system runs as a particular user, and every file is owned by someone. That ownership, that is exactly what enforces access control. Here is our roadmap for the Explainer today. We'll start with the digital security boundary, then take a peek inside the identity files. After that, we'll talk about the power of root, learn about switching identities safely, and finally finish up with building and modifying accounts. Let's get right into it. Part 1, the digital security boundary. Let's talk about users and groups. You can think of user accounts as the fundamental walls keeping our castles safe. They isolate system users, regular users, and the super users so they aren't constantly stepping on each other's toes. Now, as humans, we love names, right? We want to log in as user01 or web admin because it's just easy for us to remember. But the system, it literally doesn't care about those names internally. Instead, it distinguishes user accounts by a unique identification number known as the user ID or UID. Similarly, groups of users get a group ID or GID. If you ever run a command like ID, it spits out exactly which of these numeric codes are attached to your current session. Okay, let's dive into this, because the way Linux handles groups is actually a brilliant piece of design. A group is simply a collection of users that need to share access to files. But there are two distinct flavors here. First, every single user has exactly one primary group. Whenever you create a file, this primary group automatically becomes the group owner of that file. By default, Linux creates a user private group with the exact same name as the user, which naturally segregates everyone. But then you have secondary groups. A user can be part of tons of secondary groups, maybe a wheel group or a web admin group. These act like extra VIP access passes that let you collaborate and read files that those specific groups have rights to. Moving right along to Section 2, inside the identity files. Let's see where these accounts actually live. So where is all this identity data physically stored? Well, on a standalone machine, your account info is just sitting right there in local text files, specifically the /etc password and /etc shadow files. But let's be real, out in the wild in an enterprise environment, manually managing hundreds of local files isn't practical, no way. The system can actually query network databases instead. Things like an LDAP database, an NIS server, a Kerberos authentication server, or even an SNB server like a Windows NT domain controller. But regardless of where it's stored, a user account always boils down to a few highly specific elements. You've got your username and your numeric UID. You have that primary GID we just talked about. You also get a designated home directory like /home/LPI user, where all your personal files and hidden configuration settings live. Then there's the shell, say /bin bash, which is the program that fires up the moment you successfully authenticate. And finally, the password. But notice I said password hash. Linux doesn't just leave your password sitting there in clear text. It's a cryptographically hashed string for security, often bundled right alongside password aging policies. Which brings us to Section 3, the power of root, the superuser. Now we have to talk about the absolute ruler of our Linux castle. Let this quote really sink in for a second. The root user has unlimited power to damage the system. Literally unlimited. In Linux, the superuser is named root, and that account has a UID of exactly 0. This user has the power to bypass all normal privileges on the file system. They can delete core directories, wipe out user accounts, or inadvertently open up backdoors. So here's the absolutely crucial takeaway. If your root account is compromised, the system is completely breached and you lose total administrative control. It's roughly equivalent to the local administrator account on Windows, but honestly with way less handholding. Next up, Section 4. Switching identities safely. Let's talk about escalating access. Because root holds all that terrifying power, the golden rule of administration is this. Log in as a normal user and only escalate your privileges when you absolutely have to. If you look at this matrix, we have three main tools for the job: su, sudash, and sudo. You'll notice that su and sudash are both used to switch to a new user, and they both demand that new target user's password. But look at sudo over on the right. Sudo works on a per-command basis, and it requires your current user's password, not the target user's password, yours. Now, let's clear up the difference between those first two commands, because honestly, this trips up so many people. If you just type su and a username, it kicks off what's called a non-login shell. It switches the user, sure, but it keeps your original environment settings. But if you use su dash with that little dash, it starts a login shell. That dash sets up the shell environment exactly as if that target user had just logged in fresh from a terminal. In almost all cases, administrators should be running su dash to guarantee they get a clean, safe shell with the proper environment variables. But what if you don't want to hand out the master keys to the kingdom? This is where the sheer brilliance of sudo, substitute userdo, comes in. On some systems, root is actually configured to not even have a valid password, so literally no one can log in directly. Instead, permitted users run sudo. You type your own password to prove who you are. The system then quickly checks a highly critical file called etc sudoers. In systems like Red Hat, anyone placed in the wheel group, which is GID 10, is typically granted full sudo access to run commands as any user, including root. It's an incredibly secure way to let the guards do the king's work without ever letting them see the king's actual keys. Finally, Section 5, Building and Modifying Accounts. Let's manage some access. Let's look at how we actually build these accounts day-to-day on the command line. When you need a new user, you just type user add followed by the username. Bam! It instantly creates the profile, provisions the home directory, and sets up that private primary group we talked about earlier. To know exactly what parameters to use, it actively pulls baseline defaults, things like the valid UID range and password aging rules, straight from a config file called etc login defense. But wait, the user still can't log in yet. Root has to jump in one last time to set an initial password and actually activate the account. Now, what if you want to alter the actual blueprint of the castle? Say you want every single new user from this day forward to automatically use a different default shell, like the C shell, /bin CSH, instead of bash. You definitely don't have to manually specify it every single time. You can simply tweak a /etc/default/useradd file. By modifying these foundation files once, administrators can customize the exact default for all newly created accounts across the entire system. So we've mapped out the boundaries, dug into the identity files, covered the vital methods for privilege escalation, and learned how to forge new accounts. But I want to leave you with one final thought. Knowing that UID 0 commands absolute unquestioned authority over literally everything we've just discussed, if your root account was compromised today, what would be the very first thing to fall in your digital castle? Understanding these foundations of Linux security isn't just about passing a test. It is about defending your entire infrastructure from complete disaster. Thanks so much for joining me on this explainer, and keep exploring.